I trust that you have my podcast and or my website memorized by now. It's always just sort of sitting up there, so I won't say anything more about it. Tonight, we are going to consider this idea of the stones, that the stones will cry out. Does that sound a little familiar? The stones will cry out. That's not something I made up. That is something that the Lord Jesus said. If you remember his triumphal entry, we call it. And that was that one time in his ministry that the crowds were praising God and rejoicing and recognizing who Jesus was. Not for the right reasons, but still, just on the surface, it was such a great day. Well, it wasn't a great day for everyone. And so I'm going to read this short passage in the Gospel of Luke, chapter 19, verses 37 through 40. The whole multitude of the disciples began to praise God joyfully with a loud voice. And notice this, for all the miracles which they had seen. And so part of their rejoicing, part of their praising God was because they had seen miracles. Jesus performed them, yes, but they recognized that these things were of God. God does indeed use miracles to demonstrate himself, his power. I'm not saying that we've got all the miracles that people claim today, but God does do miracles, and we've considered the miracles of creation in several of our sessions. And so these people were praising God for the miracles which they had seen, saying, "Blessed is the King who comes in the name of the Lord, peace in heaven and glory in the highest." And some of the Pharisees in the multitude said to him, "Teacher, rebuke your disciples." And he answered and said, "I tell you, if these become silent, the stones will cry out." It's sort of interesting. What stones? Well, what was Adam made of? What were the plants made of? I mean, God just took those atoms and those molecules that were in the stones and turned them into plants and rhinos and Adam, So I don't know exactly what Jesus meant, but what a statement in this particular situation. Because, there were times when Jesus told the people, be quiet. Don't be telling everybody these miracles that I've just done. But in this case, he said, this is the appropriate time. And if people don't praise God and recognize who I am in this moment as I am entering Jerusalem as Israel's king, though I'm not going to do what they want me to do, then I'll make the stones cry out. Well, it's interesting, generally we think more of, from the biblical perspective, the heavens are the ones that cry out. The heavens are what declare the glory of God. God made the skies for, in part, that purpose. So we are familiar with God's word telling us that the sky, especially the stars, reveal the Creator's glory. Psalm 19:1 is one of those passages that indicate that. The heavens are telling of the glory of God, and their expanse is declaring the work of his hands. But we're going to let the stones of the earth teach us about their Creator tonight. And Job, way back there in that ancient book, actually says, the stones will do this too. Job 12, verses 7 and 8. But now ask the beasts, and let them teach you, and the birds of the heavens, and let them tell you, or speak to the earth, and let it teach you. There's a lot of different kinds of stones that we could use to learn from, but I trust that you understand that fossils, a lot of them, most of them, are stones, and we can learn a lot from the fossils. And what can they tell us? Well, they can tell us about things that lived in the past, and they can tell us some things in contrast to what the evolutionary community tells us, especially when it comes to the age of things and the relationship of one kind of an organism and another kind of an organism. So if the fossils are going to teach us something, maybe it's first good to make sure we know what a fossil is. It's not a watch. I've got a fossil watch. It's not one of those old curmudgeons in the back row. Good, there's no men sitting in that back row. You'd think I'm talking about him. A fossil is anything from a plant or animal that has been preserved in the earth's crust. So it's not always a bone. It could be a footprint or something like that. But it's something from a plant or animal that's preserved in the earth's crust. How are they formed? Well, the crucial factor in fossil formation is the artifact has to be buried quickly, and it's got to be buried. If it's exposed on the surface of the ground, it's going to decompose. It's pretty tough to see in this picture, but there's a vulture, the vulture's eating a dead corpse. If it's exposed for very long, it's going to disappear. But if it gets buried, then nothing can get at it but bacteria. And a lot of times they're still going to be degraded and so forth. But the two key factors for fossils being formed are they have to be buried quickly. What would bury a fossil very, very quickly? An avalanche or maybe a flood? Or a lot of silt and everything buries over top of it? These remains of the specimen will then generally be buried in layers because, for example, in a flood, you're going to have a slosh of water carrying a lot of silt or mud. It'll cover it up. But then another slosh, another flow will come. And so generally, you're going to get more than just one layer. Not always. We're going to see something where a volcanic blast made a whole lot of dust. And even though there was some layering to it, huge, thick stacks of dust. So it wasn't so much layering, but just a large body of sediment. So anyway, these layers of sediment are called strata because they'll be layers. They're stratified like that. So here's a picture. I showed you back in this one. They're using a dinosaur. He's getting buried over by a flood. Now it's buried and there's strata on top of this specimen. And then over time, the organic material is going to rot away, is going to be degraded away, usually. And the weight of the sediment on top is going to crush it, and the filtering of water through those layers goes not only through the layers, even through rock layers, but it goes through the bones. And the water will dissolve the organic material and replace it with minerals. And so literally, there is sort of like a transformation of the organic material into rock material. And so you sort of get a rock copy of what had been there that was organic. So here the fossil is buried, and I think even in this picture, they're showing you those little lines coming down. That's representing, the water as it goes through, and it's going to ultimately replace organic material with minerals. Then, over time, not necessarily a long time, then erosion will occur and tear away some of those layers. And in this particular picture, you see the jaw of that dinosaur is exposed, and somebody finds it. So, of course, they start digging in there, and they find the skeleton of this fossilized creature. So, how long does it take for the layers to form, all that sedimentary layering to form? Generally, you'll hear that for example, layers of the Grand Canyon. Have you had the privilege of seeing that magnificent geological formation? Thousands of layers. And you'll hear the story about that represents a time column of 5 million years. All right? Layer after layer, and the upthrust, and so on and so forth. I'm not going to go into their explanation much. But generally, you're going to hear about these layers representing large periods of time, each layer being a particular period of time where an ecosystem flourished, and then did the climate change? I don't know. And then you get a different kind of ecosystem, and these different layers form over a long period of time. Well, it's one thing to hypothesize how long something might take. It's another thing if you actually see it happen. And we learned a whole lot from Mount St. Helens. How many of you remember that? That was back in 1980. Boy, that's 44 years, almost 44 years ago. Well, here's a lot of research was done, especially by creationists. They were fascinated with what we might learn from actually watching the effects of a volcano. And this is a picture of the after effects from Mount St. Helens. Now, let me explain something. You can see the layering there. You're familiar with that because you can see that kind of thing in the Grand Canyon as well. On the layering like that from a volcano, what generally will be assumed is those individual layers, at least most of them, maybe not every single one, but those layers are going to represent individual eruptions. So, this layer gets laid down, and then 2,000 years later, it erupts again, and you get another layer. And so that volcanic ash layering generally could be considered to have taken 50, 100,000 years to lay down. Until then, that volcano goes completely dormant, And it's interesting, one of the details that they use to try and make the case, I say they, geologists, use to make the case that these are distinct eruptions, is there's a element called iridium. And it tends to be down deep in the earth. It's also comes from space sometimes. And there will be a specific amount of iridium in a particular eruption. And so they'll find a layer of ash with a very specific amount of iridium in it on one side of the United States, and then they'll find another layer of ash, and they'll measure the amount of iridium in it, say over in Nova Scotia. And if it's exactly the same, they go, oh, these deposits were from the same volcano, so this dust, blew all the way over to here. Okay, that's all well and good. But what we learned was, this didn't take 50,000 years. It didn't take 1,000 years. It didn't take a year. These layers, all of them, were laid down on June 12th, 1980. And you know something else that was found? Different levels of iridium in different layers in that column. In other words, at different times during the eruption, different amounts of iridium will be mixed in with the dust as it gets laid down. And all those different amounts of iridium in different layers don't necessarily mean separate eruptions at all. Now, this has then thrown a big monkey wrench into this idea of dating the periods of time between different layers, especially using iridium as a marker. Oh, by the way, see the man down there? That shows you how tall that column of layering is, that strata, 25 feet thick in just that one area, where it's called pyroclastic flows. The wind, it's like tornadoes inside those blasts, and it's just laying layer. Boom. Yes, that entire, from where that man is standing up to the top. Yep. What you're looking at is where that man is standing all the way up to the top. That area where you see a whole lot of little layers all at once, that's 25 feet thick, but the entire deposit from where the man is up to the top, that was all part of the Mount St. Helens eruption. Mm-hmm. Here's an interesting thing about suggesting that layers take a long time to be laid down. See what this is? It's a fossilized tree jutting up through a bunch of layers. Now, that tree did not grow through rock. That tree was there. The layers were laid down, obviously by some kind of a flood, something that rapidly put layer after layer after layer, and then over time, the sediment compressed, turned into stone, and you've got this tree that didn't grow up through it. You got this tree that was standing there, and then those layers came and basically covered up the tree. So there's all kinds of evidence that layering far from requiring thousands and thousands of years, generally tends to happen very, very rapidly. How many of you have seen the passes, through mountains, and you'll see layers of coal, but you've noticed that, wow, the rocks are like doing this kind of thing. This is a really, really interesting pass coming through, I think it's West Virginia, it might be Maryland. I forget where I took these pictures. And when you get up through the crest of the mountain, isn't it interesting? The layering is going the other way. The layering is forming a cup shape, but the mountain is doing this. So all of these layers obviously weren't laid down that way. If something is tilted, the layers are going to sediment in there. So to have layer after layer, it's got to be flat. But then something moved those layers, bent those layers. And if you can see at the very top, notice how curved they are. And down here near the road, you can see them curving layer after layer. Look at this one. This one is truly amazing. The thing is, what we find is those rock layers, they're not broken. They are truly folded. So how in the world are you going to get rock layers to do this when they were this, and they're not all just broken into little pieces, Well, there are two explanations for how rock can smoothly fold like this. Folding occurs while the layers are still flexible. In other words, those layers get laid down rapidly, they're soft, even though they're distinct, and then something, while they're still flexible, moves, earthquake or just movement of the crust or whatever, and those rock layers, flexible, they're plastic, basically, move, and then over time things settle down and they harden into shapes like this. The other explanation for how rock can smoothly fold is that under pressure, rock can become plastic. Now, not plastic like what's on my iPad frame here, but flexible is the descriptive term, but they call it plastic. Stone becoming plastic under pressure and heat. And then the idea is, okay, so then over a long period of time, this stone that is far enough down and the conditions are just right, it's now plastic, and then as the earth moves a little bit, shifting and so forth, it becomes folded and so forth. The thing is, when stone becomes plastic and is then misshapen, there's a process called metamorphosis, and it becomes metamorphic rock, and the crystalline structure is different. And you can tell from using microscopes and stuff, you can tell the difference whether something was metamorphic or it had become plastic, or if it was just soft and was flexible before it turned into sandstone or whatever form of rock was made. Obviously, if those layers were flexible and then they were folded, then all those layers were laid down at the same time, and it didn't take a long time for that strata to form. On the other hand, if they were plastic and then they were changed chemically over a long period of time, then those strata could represent eons of time. Well, some creation research was done just very, very recently. It was published in 2021. I'll read the title of the article. The Petrology of the Tapete Sandstone Tonneau Group. That's a place in the Grand Canyon, Arizona. The petrology is the study of the rocks. And so what the researchers did was, this is one of the areas where they studied, and it's almost impossible to see, at about the bottom right corner. Do you see the little blue shirt? If your eyes are good enough. So that shows you how large that formation is. That's a man standing there. This was part of the formations that they were studying there in the Tonto group. There's the two green bushes, and he's between the two bushes. All right. Or maybe those are trees, really. This is the results of the study. They were studying, okay, so are these folded layers, are they metamorphic rock, or are they not? The study that Dr. Snelling undertook concludes, quote, "Therefore, our 4-year research project confirms that these rocks were bent while they were still soft after rapid deposition." You get it? All those layers, one after the other, they were all still soft, and then they were bent like what you saw. This is tremendous evidence that the Grand Canyon's rock layers were laid down during a massive flood and subsequently bent before any of the layers had hardened. That is totally contrary to what you're told when you go to the Grand Canyon and you read all the things about the 5 million year period of layers forming, the Colorado River cutting through the canyon, the uplift of a tectonic plate, 5 million year process. Well, now we have strong evidence that says otherwise. So we understand that layers don't take long at all to be deposited and deformed or formed. How long does it take for a fossil to form in those different kind of strata? All right? Once buried, how long does it take for fossils to form? Well, can you see what that is? It's a hat. Dinosaurs didn't make that hat. Ichthyosaurs didn't make that hat. That's a human product, right? So it's within the period of human history when we were making hats. It's a petrified hat. Now, frankly, I'm not a geologist, so I'm not versed in what the distinction even is between a permineralized bone and a petrified hat or a petrified log, But I do know this: they both are the same in the sense that the organic material, the material that it originally was made of, is replaced with minerals and it becomes a stone. All right? So this is a petrified hat. So how long did it take to go from a leather hat to stone? Decades? That's it. Could this truly be a fossilized finger? It looks like a fossilized finger, but I mean, how could it be? How could a human finger be fossilized that quickly? I mean, we're talking skin and all, right? Well, it is a fossilized human finger. When you look carefully here, the white arrow, the bone, I don't know if you can see, there's a little whitish, lighter area, and x-rays show that there's the dense bone running the length of the finger. There are little dark spots. Those are the tendons that run through the length of the finger, and then the skin layer, the red arrow, is showing it's the epidermal layer there. They sliced it up to show that this is indeed a fossilized human finger. So again, how long did that take? When did somebody lose their finger and it got in the mud and got covered up and went through the process of fossilization? There are many iconic pictures that you may even have in your own mind of different presentations of fossils. And one of those iconic fossil presentations is the fossil progression of the horse. You got a picture in your head already of, those horses, the little Eohippus, and then it goes out to the modern horse. So we're going to look at it here. I want to point out to you that the standard explanation for the evolution of the horse that you see in those graphs is a 60 million year process. 60 million years. All right. So here it is. We've got the Eohippus. If you saw one running around in the woods, you most figure it was a dog. Okay? Then you go up through the process here until we get to the modern horse, Equus, alive today. And notice the different time spans. From Eohippus to Mesohippus. That's a 20 million year process, according to the evolutionists. 60 million years up to Mesohippus, 40 million years. So that's a 20 million year process. Then going from Mesohippus to Merychippus, that's a 15 million year progression. From Merychippus to Pliohippus, that's an 18 million year progression. So Pliohippus lived around 7 million years ago, according to this standard evolutionary scenario. And then we come to the modern horse. So remember, from Merychippus to Pliohippus is considered to be an 18 million year gap. 18 million years. We can't even fathom that span of time, but that's the gap between Merychippus, and Pliohippus. What's the big difference between these two? Well, Merychippus has a couple of extra toes. Now, these bones here in your hand are tarsals, and then the little bones down in here are the digits. Okay, metatarsals and your digits. All right. Well, Merychippus has a couple of extra, we might say, tarsals here, and then it's got its little toes. All right. It's got how many toes? 3. As horses go, it's got 2 extra toes. Then when we move up through the evolutionary time, up 18 million years, and we've got the metatarsals now virtually gone, and Pliohippus walks around on 1 toe. You see the difference there? Okay. Remember, that's an 18 million year gap. I did a conference in Nebraska many years ago, and they asked a lot of questions. Maybe, by the way, I was supposed to say this, Mike, before I started tonight. We're going to have our Q&A, and your questions do not have to be about our presentation tonight. It can be about what we talked about earlier, or something that hasn't been mentioned through the conference. Okay, so I hope that you'll ask your questions tonight. As reticent as some of you seem to be, the people at this conference were not reticent at all, and they were firing these questions at me, and like every other one had something to do with, what do you think of the ashfall fossil beds, such and such? And I go, ashfall fossil beds, I have no idea what they're talking about, So finally I found out that there's this magnificent fossil deposit not far from where the conference was, called Ashfall Fossil Beds. And it was a place where a volcano had erupted in the past. They were saying about 10 million years in the past. A volcano had erupted, and this ash nearby, it was just piling up and piling up and piling up. And for a period of time, as it kept depositing, the different animals that lived on the prairie in that area were still trying to, nose the dirt away, the ash away, and eat the grass and so forth. So they were not dying because they just got buried right away. They were dying because they were breathing in all of this ash. And when they determined the strata, they found this depression area and assumed this was a lake. And the thing was full of totally undisturbed, articulated skeletons. Because what was going on was they were getting in the lake, trying to just breathe, and they would just drown. They would just die and lay down and get covered up. And so the fossils were perfect. Nothing busted up, just magnificent. And so in that area, they find barrel-chested rhinos, saber-toothed deer, camels, all these really cool, all kinds of really neat fossils that lived in Nebraska. Of course, it wasn't Nebraska in those days. And another thing that they found were 5 different species of horses in this area. Well, here was in the museum part of the display, a horse leg display. It was really, really something. And not the modern horse, but all the other legs were excavated right there in the ashfall fossil bed. And when did they get buried? Well, we won't worry about the timing of it, but they all were buried at once, all by this one event. So here's a picture of some of those legs that they were displaying. Here are examples of 3-toed horses. Remember, the Merychippus had three toes, 2 extra toes with the metatarsals down the side. So here they are, 3-toed horses. And then in that same display, right next to them, was a two-toed horse. A two-toed horse? Wait, I thought that was the Pleiohippus that was 18 million years later. And you got the three-toed, and you got this gap, and then you get to the two-toed horse. And so I asked the gentleman very specifically, now wait a minute, these were all excavated right here at the fossil beds, right? Yeah. So they were all living at the same time. They were all buried at the same time. Yes. So the three-toed horses and the two-toed horses were living at the exact same time. So apparently the way to explain that is you've got only three-toed horses, and then you've got the two-toed horses through this gap time, and then you don't have any three-toed horses in that particular span. The thing is, do you know, I'm not an equestrian, but my understanding is, do you know that there are still examples of horses that are born today that have extra toes? You know what they do with them? Well, they kill them. No, they don't just snip their toes off. They kill them because they do not want those genes getting mixed back into the horse population. So, I mean, you've got to weed those things out. So this idea of going from three toes to two toes to no toes, to one toe, it's presented to us over these millions of years of time. The fact of the matter is, this is something that would amount to adaptation. What is probably going on here? Well, the thought was in this area, it's a plain, but it may have been a marshy area as well. Well, having one toe is nicely adapted for hard ground. That's why we've got these horses with the one hoof. They can run really good on hard ground. But how about the ones that have adapted or just would prefer to live in the marsh? Well, it's pretty nice to have a couple of flared out toes so that you don't go down in the muck and get stuck. So we've got two different species of horse that have adapted to the different environments in that very same area. This idea of millions of years of evolution doesn't fit the data, but it gets presented as the long, long period of time of horse evolution. So here, these are the 5 different species of horses that they've identified in this way. I won't even try to name them, but the top 3, look at them. They're just different kinds of horses. But they have 3 toes. They got the 2 extra on the side. And then the bottom 2 are are one-toed horses. They've lost the 2 on the side. All of them, the one there on the bottom left looks more like a donkey than a horse. But again, now this is all just speculation, an artist's rendition from the small differences in bone structure of these different species of horse. An 18 million year process from the 3-toed horse to the 1-toed horse. Well, actually they all coexisted on the plains and or the marshes of Nebraska, quote unquote. We should understand that the fossils are simply not that old. Here's a few other kinds of examples to demonstrate the fallacy of the kind of dating that's used to tell us that this fossil is 100 million years old or that fossil is 18 million years old. Remember that fossilized human finger? Well, it's amazing enough that you've got a finger that didn't even decompose. It just got buried quick enough to be petrified. But what really is problematic about this fossilized human finger is it was found in Cretaceous rock, in Cretaceous stone, layers of stone that are supposedly 110 million years old. Well, nobody thinks that humans were walking around 110 million years ago and somebody lost their finger. There's a problem with the dating of that rock. Here's a very interesting fossil. It's not a bone, it's an imprint of a hand. And Dr. Baugh has shown that it is even so realistic as to see that, if you stumble and fall in mud, it's a little slippery, so your digits are all going to sort of spread out, and catch yourself. And that's exactly, look how wide his hands are spread apart. In the middle digit there, it went all the way down into the mud, and you can see the fingernail, the impression of the fingernail as well. So there it is. That's the actual stone with the handprint in it. What's the big deal? Well, the big deal is that's dated as 100 million year old Cretaceous stone. No one thinks that human beings were walking around 100 million years ago, not even the evolutionists. And some have gone as far as to say, well, we haven't discovered this animal yet, but something had human-like hand. Maybe that's the explanation. In the Paluxy River, there are trails. The Taylor Trail is a very famous one. If you notice the man walking there, now he didn't leave the trail, he was just walking in the footprints of what anybody would look at and say, oh, those are human footprints. But lumbering off at an angle there are sauropod footprints, dinosaur footprints. Now that is the same layer of rock. It was soft when the person was walking in that direction and when the sauropod was walking in that direction, and then it got covered up, it got compressed, it turned into stone, eroded away, and here we see an example of human footprints and dinosaur footprints in the same strata of rock. These footprints are not 100 million years old, but that's how they date them. This one's really fascinating. This is the actual stone that they cut out of the riverbed, and you'll see another model in a moment, but you can see the dinosaur footprint, right? That's pretty obvious. And then just above it, you just see a little black dot. That's a big toe that's like stuck in the mud. But it's hard to see the whole footprint, but if you look carefully, can you see the toes next to the black dot there? Here's a model of it. They took a model form of it to show you. There's a human footprint with the dinosaur footprint pushed right in on top of it. Again, these are not as old as the evolutionists tell us. But to me, the most fascinating and the most powerful evidence of the problem with dating these stones and the demonstration that the dates that they come up with are unreliable is the phenomenon of soft tissue, unfossilized tissue in dinosaur bones. This is a paper published in Science by an evolutionist. This is not even a creation publication. It was published back in 2005. And there have been many, many, many examples of this now, but I'm just going to show you one of the first ones that was extremely controversial, that the evolutionists refused to accept for years. But Mary Schweitzer, she was a good scientist in many ways, and she didn't give up, and she just worked at it until she was able to demonstrate that this is dinosaur tissue, and it's unfossilized in these T-Rex bones. So the name of the article, Soft Tissue Vessels and Cellular Preservation in T-Rex. Look at some of the pictures of what was found in dinosaur bones. That's marrow. They're off to the left. I mean, that's just marrow inside the bone. The bottom right there, bottom left there, the light tan material, those are little ligaments. Now, this is magnified a fair bit, but that's not microscopic. You can see that little bit with the naked eye. Ligaments, marrow, still present in bones, totally unfossilized. Dissolving away some of the stone, dissolving away some of the bone. Then we see lots and lots of blood vessels, even blood cells. These are different stages of her dissolving away the stone material and the bone material. Then here's a microscopic, using a microscope of some of the blood vessels. Those little round dark dots, those are red blood cells, still present in the blood vessels of how old a dinosaur does this have to be? At the absolute minimum, according to the theory of evolution, 65 million years old. Now, this is ludicrous. It is absolutely ridiculous to even propose, but they do, because people just generally go, well, okay. You need to understand, this is physically impossible for protein, for connective tissue, for red blood cells to remain organic for 65 million years. Escaping the water trickling down, escaping the minerals, replacing the organic materials, escaping decomposition, and just sitting there waiting to be found 65 million years later as a red blood cell. It's ludicrous. It cannot be. But it's a given that dinosaurs went extinct 65 million years ago. And so that's how old these things have to be. So what's the problem? Well, the problem is the dating of those rocks is wrong. It doesn't need any more explanation than that, folks. It's wrong. And the dating of a 110 million year old Cretaceous stone with a human finger in it is wrong. And the idea that it takes thousands of years for petrification to take place is wrong. And we've got just so much evidence to show that. Well, another iconic fossil presentation is Lucy the ape woman. How many of you have heard of Lucy? Very interesting. Further study of this fossil, famous fossil that we're going to study, turned up the fact that it probably wasn't a female. This fossil probably was a male. So let's see. We got Lucy. What's the male version of Lucy? Ricky. Lucifer, right? We got Lucifer and Lucy. That to me is pretty ironic, that this fossil actually probably more accurately named is Lucifer. In any event, what you need to understand is Lucy is a name like man is a name. Man is a term to describe the species Homo sapien. Lucy is the term to describe the species Australopithecus afarensis. You all say this together? You'll really sound smart in your conversation at the water cooler. Australopithecus afarensis. Very good, very good. All right, well there she is. And you see her in all the museums that are going to have the human evolution displays. She supposedly was the ancestor of the human race. And notice, there she is. She's like taking a stroll down the path. All right, that's the way they present Lucy. And these pensive looks, and a lot of times she'll sort of have a finger like this, and she's sort of gazing up, having thoughts about what she's going to wear or something, This is the way Lucy is presented. This is from the Smithsonian Institute, and Australopithecus afarensis. This is what they think her face, its face, Lucy's face may have looked like. The Lucy fossil, the original one, was an astounding find. It truly was. It was found in 1974 in Ethiopia. That's Africa. The claim is that Lucy had a human-like lower body, which meant that she could walk upright, similar to modern humans. So, this part, her head and so forth, was ape-like. That's why they call it an ape woman. But the lower part, it was more human-like. And so the idea was this was the early hominid that was going to become human, and she was walking upright, so then, you could start developing tools and just be free to do the kind of things that lead to being human. The thing is, they didn't find any feet in the skeleton. So the question was, does Australopithecus afarensis have human-like feet? Because if you're going to walk like a human, you've got to have feet like a human. All right? It was 40% complete. Here it is. And notice there are no feet there, but there is a femur on one leg and the lower bones on the other. So it was amazing, a skeleton like this, to have that much of the skeleton. But problem, to expand this interpretation that this creature walked upright, was that there were no foot bones found. Well, 4 years later, in Tanzania, what was called the Latoli Trail was discovered by Mary Leakey. And what they found were what they called human-like footprints in 3-million-year-old volcanic ash. And we've already considered that idea of how they date these layers. But anyway, 3-million-year-old volcano erupted, and they're walking through the ash, and it was said that a Lucy-type hominid made these footprints. So this was claimed then to be evidence that Lucy walked upright, because these footprints, if you can see, notice how they're right in line. I mean, that is a human gait, all right? Another fascinating thing is you can see the adult-size footprints, and then right next to it you see the littler ones. Well, what was happening here is there was an adult and a child. And there are points along there where the child is walking right alongside, we'll say the mother, okay, Lucy. They're walking side by side, and then there's a portion of the trail where the child footprints move over and walk right in the footprints of the mother. Like any kid would do, walking right in mom's footprints. Well, they're saying that this is a Lucy doing this. Proof that Lucy walked upright. The problem is, one, these footprints of supposed Lucy, remember, they were found in Tanzania. Ethiopia is 1,000 miles away. And yet they said, but these are the footprints left by this creatures that we found bones of in Ethiopia. Same species. We sort of need more evidence that those bones, we don't have any feet, were walking upright like a human. Another problem is that these footprints are no different than modern human footprints. I mean, it's not like they're sort of different from an ape, but they're sort of like human-like. I mean, they are exactly like any other human footprint. What do we really have here in Latoli? We've got a person walking along with their child, and the child wants to walk in mommy's footprints for part of the way. This is just human footprints left in stone. And of course, they're not 3-million-year-old footprints. Nobody thinks that modern humans were around, even the evolutionists 3 million years ago. So there is on the right-hand side, you can see right there, you can even see the arch of the foot there. That is a modern, land-walking, upright, developed foot. Well, like we said, foot bones were not found with the original Lucy skeleton. But in 2011, foot bones were found that were considered to be Lucy-type bones. Although saying foot bones might be a stretch, because it was a toe bone. Okay, that's what was found. 2011 in Ethiopia. Well, that's good. We're back in the country where the original Lucy bones were found. And here it is. These are 4 different angles of the metatarsal that was found here. The toe bone found in Ethiopia. And again, this toe bone is virtually identical to a modern metatarsal of a human. Here's where it would fit. It's you can see the fossil, and then you bring it down to the red lines, and there's the little browner bone. That's where it that's where it would fit. And the blue line is showing that it's an arched foot, just like a human. Apes don't have an arched foot like that. They got a flat foot. So, does Australopithecus have a human-like pelvis? What we found is a modern human-like foot. We would say that it is a human foot. We found footprints in stone that are just like modern human footprints. So if those belong to Lucy, well, that's pretty powerful evidence, that you've got an ape-like creature up top and a human-like creature down below. But the key for walking like those footprints showed you in a straight line like that, being able to not, you know how apes walk, right? You've all seen apes in the zoo. Do they walk like this? When they're trying to, do they walk like this? No, they go like this, right? What are they doing? They're throwing their hip around so that they can walk. And I'm going to show you a little video here in a moment that shows you why they walk that way and show you what the pelvis actually looked like in those bones that were found back in 1974. This is a little video clip from a video called Lucy, She's No Lady. And it was made by Answers in Genesis. Dr. David Menton is the narrator. He's a medical doctor. He taught in the medical school at Washington University in St. Louis for 30-some years. He taught anatomy. He knows what he's talking about. All right? So I'm going to show you this little video clip of Dr. David Menton explaining the necessity of Lucy having a human-like hip to walk that way and to have human-like legs versus having a normal ape-like hip.
The big problem, however, are the hips. And let's look at these hip bones. There are really three bones that fit together to form the whole pelvis. I brought along the right piece of the human pelvis here. Fits right down here. And they're made of three different bones: the iliac part, the pubic part, which is right in front here, and right here is the ischium. These are the ischial tuberosities, and you are all sitting on your ischial tuberosities right now. That's what's supporting the weight through the gluteus maximus. Now, there's a distinct hip for apes and humans. And as far as I know, no overlap. You can't confuse an ape hip with a human hip. What's the big difference? Well, let me bring up a drawing that'll help to illustrate this. If you look at the top, that's a chimp. And at the bottom, that would be human. Notice the iliac blades of the human go front to back like this. It almost looks like a steering yoke on an airplane when you get them both together, right? As you look at it, isn't that sort of like a steering yoke on an airplane? See the handle here and the handle here, upside down? Whereas the ape, the iliac blades flare out laterally. So if I put this in place, in the human, this blade would be here, and the ape, it would be out here. Got the picture? This versus this. Now, why is that important? You need to have it this way if you're going to walk, as humans walk. Why is that so? My students tell me that I was at one time or another able to use almost every item of clothing on my body to illustrate things. Handkerchiefs can make muscles, and if we have a muscle that attaches to the iliac blade here called the gluteus medius, and that muscle comes down from here to here, right across there, and attaches to this bump on the femur. Now that's important because when we lift our left leg, think of an articulated dowel now. If you lift the leg, what's going to happen? If these are articulated joints at the hip, this hip's going to fall, isn't it? Lift the left leg, the left hip will fall. If I lift the right leg, the right hip will fall. What keeps this from happening? When I lift the left leg, the muscle that goes between here and here tightens up, and it keeps that from happening. See that? It's attached here. So if you don't have this orientation of the iliac blade, you cannot keep your posture as you walk perfectly even. Once again, you have to throw the weight back and forth to overcome this. Now on apes, the blade is like this. I've exaggerated a bit. The same muscle, gluteus medius, comes over the back side now. Notice that? It's going down the back. And apes have a center of gravity in front of their knees. They want to fall over forward anyway. And so this same muscle keeps them from falling further forward. So you can look at the pelvis and tell whether you're looking at an ape pelvis that cannot walk anything at all like we do, or a human pelvis. The big question is, what kind of pelvis does Lucy have? Well, Stern and Sussman said, the fact that the anterior portion of the iliac blade faces laterally in humans, he's talking at, this is facing lateral out here rather than over, but not in chimps is obvious. The marked resemblance of Lucy to the chimpanzee is equally obvious. So you get the picture? The creatures like Lucy have the ape orientation of the iliac blades. Now, what are the evolutionists going to do about that? You're not going to believe this. Nova, have you heard Nova? There was a PBS Nova series in which Dr. Owen Lovejoy, a very distinguished, famous paleoanthropologist, was involved. And he's looking at Lucy's skeleton here, and he's lamenting the fact that the hips are all wrong. They're supposed to be human-like hips, so you can walk the way the Laetoli footprints showed she walked, but they don't look like human hips, they look like ape hips. What to do about this? Watch it. You'll get a big kick out of this.
The ape that stood up, it was a revolutionary idea. We needed Owen Lovejoy's expertise again, because the evidence wasn't quite adding up. The knee looked human, but the shape of her hip didn't. Superficially, her hip resembled a chimpanzee's, which meant that Lucy couldn't possibly have walked like a modern human. But Lovejoy noticed something odd about the way the bones had been fossilized.
When I put the two parts of the pelvis together that we had, this part of the pelvis has pressed so hard and so completely into this one that it caused it to be broken into a series of individual pieces which were then fused together in later fossils.
So you see they were broken and they don't fit together properly. They did speculate in the program as to exactly who was responsible for breaking the hip, and current scientific evidence suggests perhaps a deer stepped on it. Here you can see a deer foot stepping on the bone. Isn't that a bummer? Let's see where it goes from here.
This has caused the two bones, in fact, to fit together so well that they're in an anatomically impossible position.
The perfect fit was an illusion that made Lucy's hip bones seem to flare out like a chimp's. But all was not lost.
This is a power saw, friends. You may want to put your goggles on.
Lovejoy decided he could restore the pelvis to its natural shape. He didn't want to tamper with the original, so he made a copy in plaster.
Notice he's removing whole parts, not just cutting.
He cut the damaged pieces out and put them back together the way they were before Lucy died. It was a tricky job, but after taking the kink out of the pelvis, it all fit together perfectly, like a three-dimensional jigsaw puzzle.
Look how perfect. You can read a newspaper through the hole.
As a result, the angle of the hip looks nothing like a chimp's, but a lot like ours.
Yeah, now, this is what we call science. You can teach this in the public schools, but you can't criticize it, because if you do, that would be religious.
So it's pretty amazing, isn't it? That it's too perfect. It fits together too well. So to make it fit what we need it to be, he broke it up and put it back together. And so what we learn from this is that Lucy didn't have a human-like pelvis. He was mentioning the bones. That's another aspect of the skeletal structure that they said was human-like. Won't go into that, but there are all kinds of explanations for why the bones may have been shaped that way, including there are apes today that have, they're bow-legged, so that's not purely just a human thing. And we also see the limits to which some will go to deny what the stones tell us. Romans 1 tells us that the wrath of God is revealed from heaven against all ungodliness and unrighteousness of men who suppress the truth. We saw a powerful example of the suppression of truth. Who suppress the truth in unrighteousness, because that which is known about God is evident within them, for God made it evident to them. When the people were shouting praises to God for the miracles that they had seen, giving God the glory, there was a group that told Jesus to silence them. And Jesus said, if they're silent, the stones will cry out. And the Lord not only said the stones will cry out, the stones do cry out, even today, about the truth of His creation revealed to us in Genesis chapter 1. The uniqueness of man, the amazing power displayed in the heavens, the wisdom and mind that could come up with a planet that can do what Earth does, and the moon being in the right place, and the sun being in the right place, and the ecosystems that are perfectly balanced and support one another, the diversity, the beauty. And then the most marvelous of all, that masterpiece that we talked about last night, this creature that has so many of this great God's attributes. What a shame that they're so marred. And yet we can still see aspects of our great God even in one another. And the beauty of it all is God loves us so much, desires us so much that He sent His Son to die, a horrific death and a separation between Father and Son that we can't even identify with how much terror that must have been, how painful that must have been for them both, so that we could be restored. We've got a great God, don't we? A wonderful Father. A Savior that, I don't know about you, but Jesus is my hero. I mean, He's such a great person. And it's not all just something that I have to read about in a book. He's in my life. And I have the hope and confidence that someday I'm going to go for a walk with Him. Talk about stuff. He's going to show me things that I never could have imagined. Are you looking forward to that day? I hope that some of the things that we've considered in these meetings has encouraged you, first and foremost, just about how great God is. But also your faith, because we get bombarded by experts, and sometimes it's challenging, and that's okay, because the Lord said somewhere in this book, without faith it is impossible to please Him. And so choosing to believe what His Word says at times when it's tough, and times when our reason may seem to, I don't know about that. Those are opportunities to please the Lord. Not turning your brain off, that's not what He's asking. But when we're confused, when we don't know which way to turn, we'll just turn towards Him. And that pleases Him. What an opportunity we have to have a relationship with the Creator of heaven and earth. Lord, thank You for all that You've done for us. Thank You for creating this beautiful universe, this beautiful earth, these amazing creatures. And thank You for making us a part of Your family through trusting Jesus and what He did for us. Thank You for the hope of eternal life with a body that is going to be so fantastic. I think whatever we might imagine now will just scratch the surface. Thank You for our time together this week. And I do pray, Lord, that something shared will be of real blessing to each soul here. I pray in Jesus' name.
All righty, time for questions. We've got this microphone over here. Dean will get one over there, and we'll have some questions. I got a couple to begin with here, Ben. Hey, radiocarbon dating used to be the thing when I was growing up. I mean, everything was judged by that type of of,
Yes.
you know. Is that pretty much history now?
No, carbon-14 dating is used. However, it's only used within the span of 50,000 years or so.
Oh,
It used to be, you read older literature, and it'll be talking about carbon dating millions of years
Right.
and whatever. Well, a problem arose when they started dating coal that was 100 million years old, 300 million years old, and there's carbon-14 in it. Well, that can't be. I mean, all the carbon-14 would be gone in literally a few million years. So they just, rather than assuming that, well, then there's something wrong with some of the assumptions we're using to carbon date these things. Well, carbon dating is only valid up to the point where we think things could be that young, and then they throw out everything else. So they use it for quote-unquote younger stuff, 50,000 years and younger.
Okay. Hey, my second question is this. There's been several ice ages that we hear about. Why do they make such a big deal about climate change?
Well, they don't want New York to flood. And, they blame, droughts and basically, if the weather changes, it's a bad thing. I think the weather has been changing ever since people have been around. We've got all kinds of evidence that indeed the climate of Earth is a cyclical thing. And even in, maybe look around, somebody here's lifetime. We were in a global cooling phase. The Earth's atmosphere, the Earth is a very complex system. And complex systems will be controlled, it's called homeostatically. You can't just keep it perfectly flat. It's going to be controlled by, it goes up a little bit, it goes down a little bit. And so within limits, you'll have this control. It's called homeostasis. Well, the Earth is a very complex system, and it is controlled homeostatically by the way God created it. And so this idea of climate change is just a norm for Earth. The claims that man is behind it, the effects of man is behind it. There are cross checks that God has put into the system, and when carbon dioxide increases, photosynthesis increases, which means then that oxygen increases, and it does this. So we are in a period of climate change, but that's nothing new, I would submit. And but it's being used, I think, as a power grab. If you make a problem so big that not even a country can handle it, the world has got to get together to solve this. Well, that's setting a stage for something, isn't it? A one world government. And we know we're headed towards that someday, whether it's our lifetime or whatever. And so these are some of the things that the powers that be behind everything. And I'm not talking about people. I'm not talking about conspiracies. I'm talking about the enemy of mankind himself to someday present his hero. And the world's going to go after him.
Yep. Follow the money, huh?
So let me say one other thing, because you talked about the ice ages. A standard, if we want to call it that, creation model, flood model, would be that there's been one great ice age. And certainly during that period of time, there was drastic variation, periods of melting and then cooling, but a huge ice age after the flood because of the climate changing so dramatically. And we're still in a period of it equilibrating out.
Yeah, back 300 million years ago when I was in high school, they taught us that solar sun flares really affected the Earth's climate and made it warmer. Are they still teaching that?
No, they're not teaching that, because actually that's a little wrong. In fact, it's the opposite. And what I'm going to say is sun flares do absolutely affect weather on Earth, but it doesn't, you would think, a big sun flare, it's going to warm up the Earth, but it actually is the exact opposite. The cosmic radiation from a solar flare causes our atmosphere to produce more water droplets, and we get more cloud cover, and it cools the Earth down. But solar flares definitely do affect the weather. So in periods of low solar flare activity, it's counterintuitive, but the temperature, the global temperature increases a little bit. And in periods of high solar flare activity, the Earth cools down a little bit because of cloud cover in the atmosphere.
Interesting. Somebody over here, I have a question. Yes?
Yes?
I saw a video not too long ago about
Oh, there you go.
the fact that the earth is still expanding, and the concept of the video was that creation was still happening because the earth was still expanding. Now, to me, he rested on the seventh day. That was my thought as I was watching it, but the confusion comes in, not with me, but with people thinking that all this UFO stuff and everything is being created by God right now.
Huh. Okay, you said the Earth is expanding. Do you mean the universe?
Universe.
Yeah,
that's what I meant.
the galaxies.
Universe, yeah.
Well, as best as we can tell, and there are debates about this, I'll accept it fine, because I read the Bible and it says that God stretched the heavens, so it makes perfect good sense to me that when he stretched the universe out and the galaxies are flying out there, they're still moving. The idea that just because the universe is expanding is a continuation of creation, I would not agree with that at all. And as far as God making UFOs and that kind of thing, I think that there indeed are creatures in outer space. They're called angels. And some of them are bad. And so I think a lot of the stuff that gets seen and reported, some of that may very well be demonic deception. But I definitely don't believe that God made aliens on other planets and they're coming to save us or bomb us. Either one. Pick your science fiction movie. I don't think God is doing that, and certainly He's not creating more. Like you pointed out, He created on 6 days, and on the seventh day He rested, and things have been going on since then.
All right, other questions on that side?
Yeah, I had a question. What is the process that they're calling that they use now to determine an object that they say is 40 million years old, or like that rock they found with the handprint in it, 100 million years old? You don't have to go. I'm sure it's a big process, but is there a name for that?
Yeah, it could be uranium dating, it could be potassium, strontium dating. There's a number of different radioactive elements that have what are called different isotopes. They have different weights, but it's still the same element. But some of the weighted elements are radioactive. And so they decay into a different radioactive element, or they may decay into something stable. Let's choose carbon-14. Carbon-14 is radioactive because normal carbon is carbon-12. And when it decays, it becomes nitrogen, which is 14, and nitrogen-14 is stable. So there are a number of different elements, uranium, potassium, there's a number of different elements that they'll use to do these dating techniques. Different radioactive elements have different half-lives, they're called. They decay at a different rate. Some of them, they measure that it's a millions and millions of years half-life. And then some are milliseconds, microseconds of a half-life. Carbon-14 is 5,700 years of a half-life. So what they do is, if you had a pound of carbon-14, you bury it, you come back 5,700 years later, there'll be a half a pound left. But if you come back 5,700 years more later, it won't all be gone. That half a pound will have turned into a quarter pound. So that it keeps halving. So they measure how much of one radioactive element is there, then look at how much of the product that it decays into is there, and then they assume, okay, it took so long to go from this much of this one to this much of that one. All kinds of assumptions involved in those measurements. For example, they know exactly how much this rock started out with. Well, if you're wrong on that, then your measurements literally don't mean anything. And there are other assumptions too, that if we're wrong on those assumptions, then the interpretation of the measurements are meaningless.
So if you ask like a respected evolutionist, if there is one,
Oh, sure there are.
how old the Earth actually is, because obviously if you look in 5 different textbooks, it has different dates or
Yeah, give or take.
50 billion, 10 billion, 100 billion.
Well,
what is the age of Earth? And twofold, how old is the Earth, would they say? And when did humans come into play?
You're wanting the evolutionary answer? What they would tell you? Okay, well, there is a pretty standard answer, evolutionary answer for the age of the Earth. And it's 4.5 billion years old. Okay, that's the standard. And there's pretty good agreement about that, give or take 10 million here or there. And they would say our solar system is a little older than that, but the Earth is a part of the formation of our solar system. So that's how old they say our sun is, how old, well, they're going to say the sun is a little older. But that's a standard answer, 4.5 billion, okay? And the standard answer for the universe is 13.5 to 14 billion years old. Now that's amazing because that does bounce around. I mean, they'll knock off a billion here and add a billion there. Just in my lifetime, it has bounced around by more than a factor of a billion. That's the standard answer for the age of the universe. So you go back that far, that was the Big Bang. And what was the other thing? Oh, humans. Again, there's going to be different opinions within the evolutionary community about that. Some will say that man is close to 2 million years old because they don't accept mitochondrial DNA dating. So they'll say, Lucy was back around 3 million years ago, and about 1 million years later, we've got pretty much what is human-like, both upper and lower body. Then there are those that would say that modern man, and I would say a much larger portion of the evolutionary community would say modern man is on the order of 150,000 years old. Okay? And then creationists, then there are different varieties, might agree with that and then say, well, 10,000 years ago or whatever, God picked a couple and made them human by doing what? Remember last night? What made Lucy human? Putting a spirit, endowing it with a spirit. And then, a creationist like myself and plenty of us that would say that the creation of Homo sapiens was a unique, special creation by God, and He breathed the spirit into that creature, and that was 6,000 to 10,000 years ago. And there wasn't a little population of similar looking creatures, but they didn't have a spirit running around with Adam and Eve.
So Chris, the dating thing it's a computer model, and the same guy that created the computer model for that created the model for weather. Okay, just so you know. All right? Okay. Somebody else on this side. They had their chance over there. It's your turn. Somebody have a question? Yes, sir. Coming back to you. Pass that on down, right?
So I've had this question for like 60 years. When it says God created man in his own image, does that mean the image that He made up for us to be, or does that mean we look like God? What does that mean?
Yeah. My understanding of image is the spiritual part that doesn't look like anything because there's no material there. I mean, I really think it's important to understand that image of God that we possess are attributes like God. And isn't it interesting how important it was to God that we not think of God as having an image that was a form? And so, what did God look like? He looked like nothing. He existed between those cherubim on the ark, and that was just a space there. There was no image. And he made a big deal about, don't you make an image of me, because I don't have an image like that. You know, he is spirit. And so when the word talks about us being created in his image, I believe that means as spirit possessors, we have all those attributes we talked about last night: creativity, volition, imagination, abstract thought, emotion, all these things. And, you know, there's no form to that. Now, to complicate it a little bit, though, he also uses the word likeness. We are created in his image and in his likeness. Now, there's something to be said for what's the likeness part. It may just be a synonym of image. Then again, it might be that God had in mind that he's going to be a human someday, and Jesus is going to look like us. Really, to put it properly, you know, we look like the Son of God in human form. But that is purely that's pretty speculative. But I don't think that that idea of our being image bearers has virtually anything to do with our form. It's our being, our attributes that are God-like.
Dean, got somebody on that side?
How old are the bones when they found the soft tissue? How old were those bones? Were they fossils?
Partly. Part of the skeleton was fossilized. In other words, it wasn't bone. A femur. You know what a femur is? It's that big bone. In the outer part of that femur, which is where those tissues were taken, in the outer part, some of the bone had been fossilized. In other words, the organic material of the bone was replaced with minerals, so it was rock. But then you go down in it, and it wasn't fossilized down inside. It was just unfossilized tissue. And so that's where we're saying, you can't have that tissue in there escaping fossilization or escaping just breaking down without doing anything to it. One of the toughest proteins we know of is collagen. And we've determined the half-life, like half-life of radioactive materials, we've determined the half-life of collagen. Who would have done that until they started finding it in fossils of dinosaurs? So now we're trying to think, well, does collagen have a half-life of 60 million years? And the half-life of collagen is on the order of not even 1,000 years. So you can imagine, okay, if that stuff's in there for 1,000 years, half of it's going to be gone. Another 1,000 years, a quarter of it's going to be gone. Another 1,000 years, there's not going to be anything left after just several thousand years. It's going to be gone. Just breaking down. The chemical bonds in those complex molecules are very energetic. And energy just dissipates. And so the chemical bonds break down, and instead of having a nice piece of collagen, you've just got little bits of organic material, and then you've got carbon dioxide and water. So they date those things using those radiometric dating, and the minimum a dinosaur bone can be, according to the theory of evolution, is 65 million years old. That's when all dinosaurs went extinct. A meteor hit the earth and wiped them all out 65 million years ago. That's according to the theory of evolution. And they've put a stake in the ground on that, really backed themselves in a corner. So they're saying that, I think in that particular paper, they were dating that T-Rex at around 80 million years. It might have been a little less. I don't remember the exact number. So that's how old they're saying it is, but it simply cannot be that old. How old is it? Well, I haven't heard any estimates on, But some of it was fossilized. But then portions of it weren't. And that's just impossible for it to be that old and to not be fossilized. Frankly, I think something 65 million years old wouldn't be a fossil that old. It would be broken down. I mean, stone will break down over a long enough period of time. So the imaginary ages that are thrown around, it's just to give you a sense that, well, enough time passes, anything can happen. Well, that isn't true. One thing very certain will happen. Given enough time, everything will break down into its absolute lowest energy state form. That's called the second law of thermodynamics. And put it in a system, it just doesn't matter. Second law will just inexorably drag everything down until it becomes at its lowest energy state. And you aren't going to have blood vessels hanging around for 65 million years.
So, Ben, I
Yeah.
promise that we got another question? Okay, all righty.
Just a curiosity. You showed on the video that we saw that they were able to find tissue, not bone, but tissue in the dinosaur, I think it was.
Right? That wasn't in the video, but that was in those slides I showed you, yes.
So, okay, so has anybody said, because there is soft tissue here, has anybody taken a chunk of that and did the DNA analysis on it?
Not to my knowledge yet. I got to believe that they would be trying that, for sure.
That's what I wondered, if there's somebody that says, oh, well, let's take it apart and
Yeah.
see if there's what the DNA is.
Yeah, I don't know. I know they're doing it with the protein, studying the protein, but whether or not they've been able to get enough DNA that's intact to do that, I don't know. I've not heard of it.
So my question was going along with that. They discovered a woolly mammoth in the ice and found soft tissue in that woolly mammoth, and they
It
said
just got frozen.
and they said that they were going to clone it. Okay, is Jurassic Park possible?
The problem is, just because you have DNA doesn't mean that you've got a functional egg from something that's alive today that DNA will work in. Right? So like a woolly mammoth, what are we going to have to use? We're going to have to use the egg of an elephant. It's as close as we can get to it, Well, taking the nucleus out of that egg and putting in the nucleus from a woolly mammoth and hope then that starts dividing and you get a viable organism is pretty shaky business, because you've got to have the proteins in that egg working with the DNA of something that's quite different. And, if they don't work, then it might divide a few times, but it's not just going to go to a fetus and then full term. So they're trying it, and I'm sure they'll keep trying it. It's a pretty cool idea, but whether or not anybody's successful, we'll see.
So we'll end up with a fuzzy Dumbo, huh? Is that what you're saying? Fuzzy Dumbo.
Yeah,
elephant
maybe.
that's woolly.
You got to figure it would have certain attributes that were not purely woolly mammoths. Yeah. Well, no, it's the same thing. I mean, cloning, it's taking DNA and putting it into a cell. You've got to have a germ cell to have it. Yeah, I don't think they could clone it. Maybe they could find a woolly mammoth male and a woolly mammoth female and try to actually, have a conception there in the test tube. But
I think, Ben, we're in a hairy situation here.
Yeah.
A lot of woolly going on here. What do you think?
Yeah.
I tell you what.
Dan, did you have a question?
You have some more questions? I was going to keep our time down, but if you got more, I tell you what. Why don't we just let Dan? You can ask him the question afterwards. How about that? Is that all right? Or do you want to do it publicly?
Huh?
You want to do your question? Go for it.
I was just wondering what your opinion was on during the Ice Age about that woolly mammoth that they found. And they said the meat was so preserved so well you could eat it.
Yeah, I wouldn't eat it. I'd rather eat a McDonald's hamburger than than that. Well, there's not much to say as far as, they have found these animals buried, and we freeze meat all the time, right? And so they have found these animals buried. They found this fantastic horse in Siberia just not long ago. It was in great shape. The hair, everything was just fine. And it was very, very well preserved. Now, again, they're evolutionists. There's 20,000 years ago or whatever. Yeah, right. Global warming, global cooling, that thing is going to manage to escape all of that for that long a period of time? I don't think so. But you can fast freeze these things and preserve it and then we find them. I wouldn't eat it, though. I don't think I wouldn't eat it, but maybe somebody did. I bet you they got sick.
How do you season a woolly mammoth anyway? I guess. Thank you all for coming to these sessions, and I think we need to appreciate our speaker. What do you think?
Thank you. Thank you very much.
Ben, appreciate your work here, and
I've had a blast.
You left us with a bang here. I like this last session a lot.
All right.
So I want to thank you all for coming and being a part of this. We always think, well, should we do this again? Is it something that is wanted, needed, and all that stuff? And we'll evaluate this one and then determine that. But I sure appreciate you coming and being a part of this and just being curious and desiring to bring God's word up to date and just to deal with it in a new way. So thank you for all that. Thank you for being here, and you guys have a good night. All righty? Take care.